Hi there. We're going to go ahead and move on to another idea in hypothesis testing, this thing called a p-value, and understanding what this idea of alpha is. So, actually, let's kind of start talking about alpha. Alpha is represented by this little symbol here, okay? And so that is the Greek letter for alpha, first letter in the Greek alphabet. And that is going to represent in statistics what's called the size of the rejection region. So if we get a sample that is in that rejection region, we would reject the claim. So let's get a concrete example in mind. Yesterday, we had this problem, and it was about the proportion of people who disapprove of the governor. And then we were talking about what's going to happen after he runs these series of ads. So P was the proportion of the residents who disapprove of the governor after the TV ads. And the null hypothesis is that is at 30%, which is where it was before the ads. But we wonder after ads had run, has it decreased that? Okay, so here's how this works then. We then come on over here and let's go ahead and draw in what we're going to be talking about. So let's just pretend that this is our problem here. And our null hypothesis, of course, is going to be centered here in this middle. And that's our HO, our null hypothesis, that says the proportion of negatives would be 30%. Okay? All right, now we know that, remember from our last unit, that if this is the true answer, if this is the true population parameter, then all the samples will be centered around that value. So we have all these p hats. So this is a proportion, or this is a sample I take of voters, and this is a sample I take of voters, and we have the less disapproving. This is a sample that has a little more disapproving of the governor. Anyway, so these are all happening because of sampling variability. We have all these different proportions. All right, so there's what's happening. And so now, and of course we will get some of these ones down here and so on and so forth. All right, so now let's put in our rejection region that is called alpha. And so I'm going to draw a line here. This is alpha. And we're going to end up later discussing a number for that. We're going to, it will default to 5% if we are not told an alpha. Sometimes we're told an alpha, but if we are not told an alpha, then it might default to 5%. But we know that this is the size of the rejection region. Okay. All right, so now that means if anything is in that rejection region, if I happen to get one of these samples down here, then that's far enough away from the null hypothesis that I get a little concerned. I'm thinking, that's more than 2 standard deviations. Remember that whole idea? So I'm thinking, whoa, I got that sample right there. I'm thinking, I'm a little worried that the data might not really be centered around this place here of 30%. So if it's not centered there, then I would reject this and say, I don't think you're centered there. I think you are actually centered a little bit lower. Maybe this curve actually is about like this and centered at this location. Now, we aren't going to put a number on where its new location is centered, but we then speculate. See, we rejected that null hypothesis and say, I think I have evidence that the negatives have gotten smaller. See, and that's what we were wondering about on this problem. Is there evidence that it has gotten lower? And so we would look then here, and that's what we were wondering. Has it gotten lower? Okay, So here we go. Now, moving on to this next one. Oops. So here we go. Now, let's go ahead. I'm going to fix that back, and let's talk what this thing called a p-value is. So here we go. So let me put all of our data back. So let's say we have our null hypothesis, and we have, these are samples. Okay. So here is our H. So if the HO is true, this is where our data is centered. And you know what? That's actually going to play into our definition of a p-value. So I just said, if the null is true, right here, let's see. Okay, the p-value is the probability of getting the specific sample results we got right here. If the data is truly centered around where it is claimed to be centered. So if the data is really centered here at HO, then let's do our p-value. So I'm going to put this unusual sample down here. Here's a sample. I actually think I want to move that. I don't want that one to be too unusual. I'm going to move that one up a little. Okay, so let's say that sample is like right here. Okay. All right, then here we go. Here's the p-value. P-value, draw a little dotted line here. We're going to draw it. P-value is the probability of getting that p-hat, this particular sample right here, or something more extreme. So in this case, more extreme is down in the lower direction. If we had a sample up top, then more extreme would be above. Okay, so this blue area right here is the p-value. The p-value is the probability of getting this sample or something more extreme. So it's this probability right here if the data is really centered around a null hypothesis of whatever. Okay? And so that is what our definition says. P-value, in fact, this is the definition that started all of my songs because this is such an important definition that this began them all. So let's take a look. Do you remember when we used to sing? We're going to sing this. The p-value is the probability. So we're going to compute that of getting this sample or something more extreme if the null is true. So if the data is really centered here. So let's go put this into work. I think it'll make more sense when we do a real problem. So let's do that. Here we go. Here's our first example. So here we have census data for Parker County. It says that there's 19% of the adult residences in Parker County are Hispanic. So suppose that 72 people are called for jury duty, and only 9 of them are Hispanic. A lawyer for the defendant thinks his client might not get a fair trial because there are too few Hispanic peers on the jury. Do these sample results call into question the fairness of the jury selection system? Provide statistical evidence. So, wow, what is that? What all is that about? So, let's think about it. What population information do we know? And the population information we know is that 19% of the Parker County, that's the population we're talking about, 19% of Parker County are Hispanic. Okay, then we're going to take a sample of that. We're going to take people to go get called in for jury. So we just get 9 of them are Hispanic out of the 72. So what we're trying to figure out is this. Let's define our parameter. First, mean or proportion. Well, I can tell you from here on out, we're going to be doing proportions for a while. So we've got a proportion. So here we go. So P equals, okay, proportion of jurors ones who are called in to be on the jury who are Hispanic. And and by jurors, I mean, I guess what I should really say are those called for jury duty. Because I don't think they pick all 70. They call in 72 people, and then from that, they might just pick 12 or whatever. Okay. So P is the proportion of jurors who are Hispanic. Okay, so those who get called in for jury duty is probably what I should say, who are Hispanic. Okay, well, if there is no prejudice happening in the selection system, what will our null hypothesis be? Okay, so if there is no prejudice happening or discrimination and there's fairness and we get a representative sample of what's in Parker County, then the proportion that get called in for jury duty is going to be 19%. All right. That kind of is saying the jury system is fair. In fact, we might want to make a little note. We could make a note and say, okay, what is that really telling us? That's kind of saying the jury selection system is fair. It's providing a representative sample of the county. Okay, well, what's the alternative? What do we fear might be happening? And so that is that we say HA, the alternative is that we have too few. HA, we are worried that the jury selection is bringing in too few Hispanics. Okay, so that is our alternative hypothesis. And of course, that is then saying that in this case, that the jury selection system, is not representing Hispanics well. Okay, so that's what we got. So we know that part. We've already kind of been doing that. So now let's talk about the new stuff. First, we're going to actually compute a p-value. And this stuff here should look familiar. Huh, what is going on here? Have you seen all of this before? Yes, you have. That is what we just tested on last week, my friends. So here we go. There is our population parameter, 0.19. That is what is in Parker County. And then what size sample do they take? They take a sample of 72 jurors. All right, now we're wondering this mean of the p-hats. Do you remember? We're seeing, and remember, I'll just kind of draw you a picture. Here's what we're wondering, okay? So if the jury selection system is fair, then we should have about our data centered around 19% Hispanics that are called in for jury duty. Okay? All right, so see here, the mean of the p-hats? Okay, that's our 0.19, or 19%. If the jury selection system is fair, all of our samples will be centered around 19%. Okay, now we got to go over here and we got to do this standard deviation thing. And so remember that we go like this. We say square root of, and then we put inside there the little 19%, okay? So that's our 0.19 times 1 minus 0.19, which is 81, okay? And we have that all divided by n. What was our sample size? 72. Okay, so there we go. There we have it. There's what's inside there. And let me sneak over here and figure out what my answer was for that without computing. And that was 0.046. Okay, so that equals 0.046. All right, now, okay, so look here, p-hat. What p-hat are we investigating? The p-hat we are investigating is the one that is 9 out of 72. Okay, so some of y'all missed that on your last test. You did not want to do that little, make it into a fraction. You just put 9 there. Or on the test, it was a 10, I think. So anyway, 9 out of 72, which is 0.125. You could round to 0.13 if you wanted. I don't know if I did on the answer key. No, I didn't. Okay, cool. All right. So I'm going to draw that picture on here. I want to draw that particular sample. Here it is. There's the p hat I'm investigating. I want to know, is that far enough away that it makes me wonder if the data is really centered around 19%? That's what we're wondering. Okay, so then in order to know if it's really far away, I need to see how many standard deviations it is away. So I'm going to get a z-score. Okay, so you know how to do that. So let's see. How far is this p hat away from the middle where it's supposed to be centered? So that's 0.125 minus that 0.19 where it's supposed to be centered over this standard deviation, 0.046. And I think that's 1 point something. Yep, negative, because see, it's below the mean. So that's negative 1.41. Okay, so guess what? Remember what we did after that? We computed the probability of going lower, and this is called the p-value. That is the p-value. It is the probability of getting that sample or something more extreme if the data is centered where you say it should be centered. Okay, so that's our p-value. That's why it's so important to understand what that is. Okay, so I'm going to write that out here. So actually, I'm going to type it because it's easier for me to do that. So here I'm going to type that in, that we've got this. Let's see, what is that? P-value equals norm CDF from it's lower, so that's negative 99, up to that negative 1.41, and that equals 0.079. Okay. All right, so there is our p-value. It is that. So remember last unit when I asked you to find probability, problem after problem after problem after problem, find the probability of this, find the probability of that. You were finding the p-value, the probability of getting that sample or something more extreme if the null is true. Okay, so here we go. Here's the ultimate lesson for today. Interpret in context the p-value. So I'm going to give you a couple little hints to go by. Okay, there's 3 things we're going to be looking for. First, p-value is the probability of getting this sample or something more extreme if the null is true. Okay, so you could kind of think about those 3 things as we write this definition. Okay, so let's see here. There we go. Okay, so we want those the p-value is the probability of getting that sample or something more extreme if the null is true. Okay, so there's that. Let's fill it in. So let's kind of do these 3 things. All right, p-value 7.9. So here I go. There is a 7.9% chance. That's the p-value, is the probability. There is a 7.9% chance of getting these sample results. What are the sample results that we got? This is the sample results that we got, this p hat, okay? There's a 7.9% chance of getting, here's the second part, C, of getting, what did we get? We got 9. What's more extreme? Which way is more extreme? Okay, was less. Okay, so of getting 9, let's just do equal to right now at this point. Of getting 9 out of 72 jurors who are Hispanic, okay, of getting jurors who are Hispanic, if, okay, so I'm trying to keep this piece by piece. Okay, so there's 9, that's the probability of getting 9 out of 72 jurors who are Hispanic if the null is true. So we could say if the proportion of jurors called to jury duty is 19%, who are Hispanic is 19%. Because see, I could just say if the proportion of those called for jury duty who are Hispanic is 19%, that's basically if the null is true. Okay, so then that's what I'm going to write there. If the proportion of those called for jury duty who are Hispanic is 19%. That's it. So, in summary, if the data is, oh wait, here we go. If the proportion of those called to jury duty is 19%. So that is telling me this. If the data is centered around 19%, in fact, we're going to draw this as we go along. Include HO and its value. So I did. Here it is, 0.19. Okay, so there's 0.19. Include HO and its value. Include some sample proportions. That's all my little p hats I'm putting in here. Okay, so that's this. If the proportion of those called for jury duty who are Hispanic is 19%, that's this what I've drawn right now. Okay? Indicate the sample results in this problem. Where were the sample results in our problem? Right here. It was this p hat, which was 9 out of 72. Okay? So I did that. Then there's of getting, that's this right here, of getting 9 out of 72 jurors who are Hispanic. Okay? And then identify and shade the p-value. That is this area here. That is, there is a 7.9% chance. So I'm going to identify it. This is the p-value equals 7.9%. And that's that right there. Okay, so in summary, look at what we got. If the proportion of those called to jury duty is 19% Hispanic, then there is just a 7.9% chance of getting the sample we got that had just 9 out of 72 jurors who were Hispanic. Okay, I know that's a lot of figuring that out. So that's why we're going to spend a couple of days making sure we get all of those things stated correctly. So let's move on to the next one and see if it goes a little smoother. So here we go. Let's try it. All right, first question, or this problem says, during the 2010 I think it's MLB season. Okay, so during the 2010 season, a random selection of 240 regular season MLB games produced 138 wins by the home team. Is this strong evidence of the legend of the home field advantage? Okay, so I gave you some hints here. It says, if there is no home field advantage, then the team will win half of its regular season games at home. And if there is a home field advantage, the team will win more than half of its regular season games at home. So what are we measuring? What's going to tell us if we have a home field advantage or not? What proportion? Well, P equals the proportion of regular season games won by the home team. Okay, so we want to investigate what proportion of regular season games are won by the home team. Okay, so what would our null hypothesis be? Nothing special is happening. Okay, no legend, no effect, no legend of a home field advantage. That would mean P equals 50%. Okay. If there is a home field advantage, then what is the effect? Then P is now going to be greater than 50%. Okay, so I like to make little notes, so I'm going to kind of do that here also. I'm going to type in this section and say, okay, so what did this one on the left mean? This one meant there is no home field advantage. The winning rate is the same whether you're home or away. Okay, and then on the right-hand side, you win more than 50%. So this one would say there is a home field advantage. Okay. Alrighty then. So I'm going to give you a few minutes. In fact, I'm going to pause this here and just you pause the video and take a few minutes to do your computing of your p-value because that you should already kind of know how to do. So let's give you a few moments to compute this little section here. All right, so pause your video. All right, so if we come back here, then here are the results that we get. We know that the data would be centered around the 50%. Here I get a null, or I get a 0.032 is my, once I fill everything in here. All right, and the sample results that we got they got a result of 138 wins out of the 240. So that's what we have here, 138 wins out of the 240. And we're going to see what that does for us. So that's 0.58. Okay, so see, we can't, so here's something that my students wonder. Okay, so this is a good discussion here. My students say, hey, of course there's a home field advantage because look, I got a sample that was 0.58. So yes, it is more than 50%. So I got this sample right here, 0.58. Okay, but here's the thing. Is this sample just a little bit far away from the middle, or is it a lot far away from the middle? Is it far enough away that we go, whoa, I'm going to reject the null hypothesis and conclude the data is centered greater? Okay, so is it far enough away? Is it unusually high? Or is this just sampling variability? You know, you get different data from season to season because of sampling variability. You get different data than me because of sampling variability. Okay, so we need to know just how far is it away. And that's why we did the standard deviation. So we get our z-score, of course, by doing the 0.58 minus the 0.50 over that standard deviation, and we come up with a p-value, or I'm sorry, a z-score 2.5. Okay, so that's pretty far out there. Remember how we used to say, what's unusual? What's an outlier amount? Well, something that is more than 2 standard deviations. So let's compute that p-value. Okay, so actually I'm going to draw that p-value on here. P-value is the probability of getting this sample or something more extreme. So in this case, more extreme is going up. So when I compute that p-value, then I say, okay, my p-value is the norm CDF from 2.5 to 99. And that amount is pretty small. I think it's 0.13 maybe. No, 0.62. Okay. So that's um, 0.0062. So only, wow. So that's really small. So just a 0.62% chance. Okay. So that is our p-value. All right. So now let's write this out. Okay. Let's remember our three things, our three statements. So the p-value is the probability of getting this sample, or something more extreme if the null is true. I don't think I played that song for you. Here I am sitting here singing it, and I didn't play it for you, but that I think about that song every time I go through writing out my p-value definition. So hey, you know what? Let's do it. You want to hear that song? Well, let's hear it. I'm gonna move out of the way so you don't sit there and watch me sing to it. Okay, here we go.
Do you remember when we used to sing? The p-value is the probability of getting this sample or something more extreme if the null is true. The p-value is the probability of getting this sample or something more extreme if the null is true.
All right. So there we go. There is our p-value definition. And so that's the one that that's what I keep singing. And you're like, what are you singing? So the p-value is the probability of getting this sample or something more extreme if the null is true. Okay, so let's do this one in context. Okay, so probability. How do I say that? Okay, I'll do this in a different color. So probability, p-value 0.62%. Not very likely. There is a 0.62% chance. Wow, not very likely. Okay, so there's the first line of getting, okay, this sample results. So what sample? Oh, it's right here. It's actually right here where this p hat is. Of getting 138 out of getting 138 out of 240 games won by the home team. Okay, there's the second sentence. If the data is really centered there at 50%. So let's look. I gotta somehow say this in words. If the null is true. Okay. So we could say what I have in red. That works too. And I kind of think that makes sense. If we could say if there is no home field advantage. Or we could say if the proportion of games won by the home team is just 50%. If the home team only wins 50% of its game. Okay. I kind of like what's in red. If there is no home field advantage. So let's write that in there. Okay, of getting this one won by the home team. If there is no home field advantage. Okay, so all together, this is saying, hey, there's only a 0.62% chance, really small, that we would have gotten 138 out of 240 games won by the home team if there is no home field advantage. So I'm going to say this one other way because I found that my AP students, My AP students actually liked it if I kind of rearranged this and said this null is true first. So let me read that and see if you like how that sounds. If there is no home field advantage, then there was only a 0.62% chance that the I would have gotten 138 out of 240 games won by the home team. So hopefully this is prompting us to do actually what we're going to do you know after this lesson, after this topic, is say, so therefore I think there is a home field advantage. That's kind of where we're headed with this, is to make a decision to reject or not reject that null hypothesis. Okay, so let's come on down here and draw a picture of what this situation says. So this is include the null hypothesis and its value. Okay, so that's going to be the 50% of games. So here's no home field advantage. We got 50% of games won by the home team. Sometimes it's exactly 50%, sometimes it's a little more than 50%, and so on. So we get all these little things, sometimes a little more, sometimes a little less. You get different data than me because of sampling variability. Okay, sometimes more, sometimes less. All right, now what's next? Include sample proportions. Okay, I did. That's on my little p hats. Okay. Oh, indicate the sample results in this problem. Okay, how do I know where to draw that? Well, this right here. This tells me where to place my sample p hat. 2.5 standard deviations above the mean. So here I go. Here's like 1, 2.5. So look, I think my p, the sample results I got were about right there. Okay. So that's what I got. Indicate the sample results in this problem. Okay. Identify and shade the p-value. So the p-value is the probability of getting this sample or something more extreme if the null is true. So if the data is really centered here. Now it says identify it and shade it. So I need to come down here and say that is the p-value, which equals 0.62%, very small chance. And I'm going to make this better because you can hardly see my sample. There's my sample results. Okay, so that is what this idea of p-value is. It's kind of, I'm trying to make it where we can draw a picture of it because it's kind of weird and strange, but we have to be able to understand this is why I started all my songs. This is the most important foundational concept so that we can then understand why we make a decision to reject or fail to reject when we make a conclusion of the big decision that we make, the big decision. Okay, so I hope that this is going to take a little bit of time for you to digest these three ideas, the three things that we must include in our definition of a p-value. All right, so good luck to you on your practice of writing your p-value definitions.